Eyes on Enterprise, where I'll be bringing on my lovely colleagues to talk about the tech, strategies, and best practices that are helping to shape enterprises today. My name is Stephanie Wong, developer advocate, and today I have Sam Stoelinga on the show, customer engineer, and we're going to be talking about hybrid and multi-cloud and how to approach that. So, Sam, thanks for being on the show today.
Yeah, thank you for having me. Happy to talk about hybrid and multi-cloud today, and yeah, let's get started.
First off, no large enterprise, no matter how well prepared, can simply move to the cloud in one fell swoop, even if their goal is to migrate completely to the cloud, hence multi-cloud and hybrid. So, can you help us define both of those in the context of an enterprise?
Workloads and processes are unique across different enterprises, and that's why you also see the term hybrid and multi-cloud be used inconsistently. So let's get started with hybrid cloud. So hybrid cloud is really where you have a private on-prem data center, and you're using a public cloud. And how can you have workloads that are interconnected and be deployed across these two different environments? Multi-cloud, on the other hand, is really focused on what if you have several cloud providers, public clouds, and also possibly a private cloud or on-prem data center, and how can you use these all together for your workloads? Multi-cloud, on the other hand, can also mean if you only have one cloud provider, but you want to make sure that your workloads are ready to be ported when needed.
Yeah, so what's interesting here is it's more about the architectural portability and readiness of your workloads. And one other thing you mentioned was it's more about the extension of your private network into the cloud or from cloud to cloud.
Yes, that's one technology to enable a hybrid cloud. So we have two technologies that really enable you to extend your private data center to the cloud, where you can even treat the cloud as an additional rack, if you would like to say it that way. So there's a dedicated interconnect and there's the cloud VPN. And both allow you to span a private network that's running on-prem and connect it to the private network that's running in Google Cloud, which we call a VPC network. And that allows you to advertise the on-prem network to the cloud and the cloud network to on-prem. So any user that's on-prem can also directly access any cloud service that's exposed only over the private VPC network.
Now, it's clear that at this point, there are a lot of misconceptions about hybrid and multi-cloud. So I want to talk about the top 3 misconceptions that I've heard, and I want to hear what you think of them. So the first one is that there is a hybrid product that makes my workloads hybrid.
Yeah, so I've had questions where I would get asked, like, what is your hybrid cloud product? And then they would assume that there is a product that takes their workload and makes it automatically run across their private data center and on the public cloud. And they would expect benefits that they get out from it, like lower cost, better reliability, etc. However, I noticed that I don't think there's such a product that exists. Actually, hybrid cloud is more about a set of technologies that may or may not be adopted by different kind of workloads. So let's say we have a batch processing workload. That workload needs to be run every night, and it needs to be finished within 4 hours before the next day begins. The enterprise has a hybrid strategy that they want to use their existing investments for on-premise as much as possible. So every workload owner is encouraged to use that first, but for any excess capacity, they need to go to the cloud because they don't want to invest more in on-premise, but they want to make sure they keep the existing investments and make the most out of them. So what they do is they have an interconnect, and the batch processing workload spins up more VMs in the cloud, and then it does some processing, and it sends the results back to on-prem. So the data stays on-prem. Some capacity is being used from on-prem, but the majority for this work needs to be in the cloud because otherwise they couldn't finish within 4 hours. Mm-hmm. So it's really a good example of one hybrid architecture that's useful for this workload. However, for other workloads, you might see a different kind of hybrid architecture.
Right. I think that's really interesting because, again, it's more about the feature and technology that enables you to burst or have better redundancy by moving to the cloud.
Yeah.
So I want to talk about my second misconception, which is that by moving to the public cloud, that inherently makes your workloads publicly facing to the internet.
Yeah, no, it comes from the name. A public cloud means everything has to be public, right? So that's I would say it's not unheard of that people think that way. However, that's not true. You can simply expose your workloads over a VPC network only, and then bridge that VPC network with your on-prem using the interconnect or the cloud VPN that we have talked about previously.
Now for the third misconception. Moving to hybrid and multi-cloud means moving everything at once.
Yeah, I think that really comes from the fact that people have workloads that always have many other dependencies. And these dependencies often reside on-prem as well. So they assume that the fact that they move the workload, they also need to move all the dependencies with it. However, that's not the case. Like we explained earlier, we have hybrid cloud connectivity, which allows you to move the workload, but still keep the dependencies on-prem.
Do you mean like running your legacy backend systems on premise, or your database on premise and then your Kubernetes engine front end in the cloud?
Yeah, I think that would be a great example of how you could migrate your workloads with all its dependencies. Yeah.
Let's move on to deciding on a strategy, because I know an estimated 88% of organizations are adopting multi-cloud today. And that can be for many reasons. One being risk reduction. They don't want to put all their eggs in one basket. Another being architectural similarity, like for like between clouds, or maybe even best of breed or feature availability in each cloud. Have you seen any other motivating factors for companies?
So I think you mostly captured it. Most customers, they want to reduce the lock-in. They have to any vendor. They want to have the leverage over the vendors versus losing that altogether. And they want to be able to choose the cloud provider that provides them with the best service.
What about maintaining consistency across environments? You need consistent tooling that's simple, that allows you to manage things like access policies, and you might have dependencies between applications and needs for performance and latency requirements.
Yeah, no, exactly. And that's maintaining consistency can be a challenge. That's also why Google has several tools available, such as containers, Kubernetes, and Anthos that allow you to maintain consistency across different environments.
Now that we've talked about the foundations of hybrid and multi-cloud, I do want to talk about a specific case study. What are some typical use cases in which performance, storage cost, or modernization of existing apps were key reasons to migrate?
So yeah, I'm working with this customer today. They're trying to modernize their whole on-prem IT stack. And they're running a CI/CD workload, Jenkins currently on-prem. And their technical requirements were they need to be able to access the on-prem artifact storage. And the on-prem users need to be able to access the Jenkins instance as well. So with these requirements, they came to us and they said, we want GK on-prem.
So it was clear to them that they needed to continue running Jenkins, but on GKE on-premise.
Yeah, well, that's what they told. But then we started talking more and more, and we found out that, hey, we actually can run all these things, matching these requirements, while still running it on the cloud. So we introduced this customer to several features, one of them being GKE private masters and private nodes, which allows you to run GKE clusters in a fully private fashion. So none of the GKE workloads are exposed publicly. The GKE nodes themselves do not even have a public IP address. Everything is directly available over the private network, which is connected to on-prem. And at the same time, this allows them to run Jenkins on top of GKE while still being able to access the artifact storage. So in this way, we had a hybrid solution for this customer by moving part of their CI/CD stack to the cloud while still being able to connect to on-prem.
That's interesting, and I think it clarifies that you do need to have a product and networking understanding to know that you can actually restrict access to public endpoints for a private GKE cluster.
Yeah, no, networking experience is always needed. Even people think they move to the cloud, they don't need network engineers anymore, but networking knowledge is required even in the cloud.
So let's talk about migrations now. In most cases, migrations is a one-time, irreversible effort, but with hybrid and multi-cloud, it makes it so that you can move in phases now. So I think portability here is key. But let's say I'm an organization, I want to make my workloads portable. What would be my first step to do that?
Yeah, so the first step is to make sure that your workload is able to shift from one computing platform to another platform. And in order to do that, you need to separate the application deployment and management from the artifact of how you deliver the software itself. So there are many tools that help you do that today. And based on these tools, we can form a toolchain that helps you do this for any VM or container-based workload that you might have. So I think key here is understanding that making your workload portable doesn't mean that you have to make it cloud native. This is often a effort that is not significant to do, and people can start doing that today with the tools available.
Okay, let's get specific. Can you give me an example of a tool chain that you can use to build VM images and deploy it to any cloud then?
There are a few tools critical to such a tool chain. Mostly four, I would say. There is a CI system, there is the image builder, there's the source version control system, and all these together form a toolchain that allows you to build images that can be deployed across any platform. So let me give an example of how you would establish, like, what tools would you use for this toolchain. So for the image builder, there's a great open source tool by HashiCorp, which is called Packer, which takes in the application deployment logic and a base image, like, for example, Ubuntu or another Linux system like RHEL, and then builds an image that can be deployed across different platforms. But it's always built using the same deployment script. So this really allows you to build deployable images for any cloud platform or on-premise system. The other system is the CI system, which job is really taking the latest commit from the source version control system and building an image using that latest application software. And tying these together allows you to build a pipeline that you can now build images automatically for any platform whenever a new commit gets pushed to the source version control system. So it's a simple example of how you would do it. And most customers, they should use what they're already familiar with. So if you're using today Jenkins for CI, you should continue using that. However, if you're using another tool, you can easily plug and play different tools to build such a pipeline.
That toolchain sounds really great for workloads that have an automated way to deploy applications in VMs. But what if I have an application in a VM already and I want to deploy that to the cloud?
Yeah, so that's actually a pretty common scenario, especially for large enterprises that buy their software from a vendor, and that vendor gave them a VMware image, and that VMware image doesn't have the application separated from the image itself.
Right.
So they have no way of taking the application and deploying it on another base image that can be deployed to another cloud. So the only solution is to take that VM as is and somehow get it to the cloud. So there are two solutions that Google Cloud offers today to customers. There's Migrate for Compute Engine, which was previously known as Velostrada, which allows you to take a VM as is and migrate it to the cloud. And it has a lot of cool features. You can even migrate a VM without touching the original VM and test whether the migration was successful. So you can do a low-risk VM migration to the cloud. The other solution that I mentioned is Anthos Migrate, which allows you to take a VM and convert it to a container and run that container in the cloud. So both solutions allow you to move workloads from on-prem or other cloud providers to Google Cloud.
So when would you use one over the other then?
The two solutions are different in what kind of use case they support. So Anthos Migrate is a solution that takes a VM and converts it to a container. And because it's a more sophisticated technology, it's more limited into what kind of source workloads it can support. Migrate for Compute Engine, on the other hand, allows you to migrate much bigger range of workloads. I would say it supports most workloads that you can imagine.
In these cases, we're talking about migrating existing VM workloads. But what if I want to create a standard for creating portable applications that we can move to any cloud?
Yeah, so that's really where containers fit in. Containers really forces everyone within the company to have a standard that allows you to deploy the container the same way in any environment. However, if you start looking at how do I manage a multi-host environment, you get into a more sophisticated area. And that's really where Kubernetes comes in. So Kubernetes solves the challenge of how can I schedule containers across a set of hosts in a cluster. How can I do load balancing across these containers? How do I ensure that I can scale out when needed?
Kubernetes has become the de facto standard, but is there any difference in developer experience then?
Yeah, definitely. And that's a good thing. I think improvement in developer experience is always a good thing to have. So developers can really focus on writing the code versus worrying about whether the code works well in production and in development, because they have the same container that they build that will also gets used in development, but also gets used in production. So they're able to improve their production reliability by having this kind of developer experience.
I think it'd be helpful to jump into another scenario. Let's say that I'm a company and I've containerized some applications, but I'm still primarily using monolithic applications on premise. So how can I use Google tools to help modernize and port to the cloud?
We have a modernization platform, which we call Anthos, which allows you to modernize your applications either on-prem or in the cloud. It's based on open platforms such as Kubernetes, which we call Anthos GKE, Istio, which we call Anthos Service Mesh, and Knative, which we call Cloud Run. And these technologies really allow you to modernize in place and move to the cloud when you're ready.
What does Anthos look like for IT ops versus developers? What's the user journey like when it comes to migrating?
So I've been involved in a few Anthos deployments, and all of the cases that I've been involved, both developers and the IT team have been super engaged. Actually, not just IT, the networking team, security team, which you could consider part of IT, they have all been super engaged, especially during the initial installation, but also afterwards for making sure that the Kubernetes platform, the Anthos platform, stays running and up, and making sure the developers have a proper experience. IT operations is always going to be involved in those scenarios. And developers, on the other hand, are going to be focused on making sure their workloads get up and running successfully on Kubernetes and make sure they stay up and running. So they have different roles, but they are still both fully engaged. Yeah.
To wrap up, what are some of your views on the trends for hybrid and multi-cloud?
Yeah, so I've seen no matter which kind of customer I work with, you often see them standardizing on Kubernetes as the platform for workloads to be running for the future, but also for current workloads to be migrated to. And even industries that are traditionally been slower to adopt newer technologies, they're also starting to adopt Kubernetes as the standard for their internal applications and external or any application. Yeah.
So for those people in that bucket, what can they do to get started and get some value out of cloud today?
I think that the biggest thing they should do is just get started with a smaller pilot, like find a workload that they want to modernize right now, get it running on Kubernetes, see what benefits they gain from doing that, and repeat that for other workloads as well. But really, sometimes it's more just get it done and get started.
Sam, thank you so much for being on the show.
No, thank you for having me. It was fun. Yep.
Everyone, check out the articles on hybrid and multi-cloud at the links below and comment with your own experience with it as well. Join us next time for Eyes on Enterprise.